Hey guys, welcome back to my channel, and in this video we are going to see about multimedia data mining, which is a type of data mining. Multimedia data mining is any type of information medium that can be represented, processed, stored and transmitted over network in digital form, which includes multilingual text, numeric images, video, audio, graphical, temporal, relational and categorical data. It is a subfield of data mining that deals with an extraction of implicit knowledge, multimedia data relationships, or other patterns not explicitly stored in multimedia databases. It is the discovery of interesting patterns from multimedia databases that store and manage large collections of multimedia objects, which includes image data, video data, audio data, as well as sequential data and hypertext data containing text, markups, and linkages. And these databases are the extension of the KDD rule patterns. This KDD is nothing but the knowledge discovery in databases is the process of discovering useful knowledge from a collection of data. The next slide goes with the information model. Information handled by multimedia databases is composed of media objects, derived metadata objects, temporal and spatial characteristics. The first one is the data segmentation, where the multimedia data are divided into logically interconnected segments, which is followed by the pattern extraction, mining analysis, knowledge representation, and incorporated linked patterns. The next slide goes with generalizing spatial and multimedia data. Spatial data is any type of data that directly or indirectly references a specific geographical area or location. Sometimes called geospatial data or geographic information. It can also numerically represent a physical object in a geographic coordinate system. Say, for example, in a road map. A road map is a two-dimensional object that contains points, lines, and polygons that can represent cities, roads, and political boundaries such as states or provinces. Moving on to the image data, it is extracted by aggregation and approximation through size, color, shape, orientation, texture, structure of the contained object or the region in the image. Moving on to the music data, it is broadly encompassing artworks that involve multiple artistic dimensions, including songs and program music as well as dance and film. It summarizes its melody and style based on some approximate patterns or some other thing like tone, tempo, musical instruments played, etc. So as we have seen already, spatial database system is nothing but which includes geometric, geographic and spatial data. In this slide, we are going to see the difference between the spatial and image database system. Image database system handles digital image which includes satellite sensing, computer tomography. It may also contain techniques for object analysis and extraction from images and some spatial database functionality. Whereas spatial database system handles objects in space that have identity and well-defined extents such as locations and relationships. In this slide, we are going to see about the function and the application examples of spatial database system. Its function is to detect the trends and the changes along a spatial dimension, say for example a particular geographical location. It is a study of non-spatial or spatial data changing with space. Moving on to the application examples, there may be changes due to climate or vegetation with increasing distance from an ocean. So it detects it observes the trend of changes in that particular area. And then the second examples goes with the crime rate or the unemployment rate change with regard to city geo distribution. This slide is a very important topic which you people have to make a very keen note of it. Constraints based clustering. So what clustering is all about? It is the most important type of process in data mining. The main work of clustering is converting a group of abstract or different objects into similar objects. Clustering is used in data mining for several reasons, which includes scalability, interpretability, high dimensionality, etc. What constrained clustering is all about? It is an approach to clustering the data while it incorporates the domain knowledge in form of constraints. All data, including input data, constraints, and domain knowledge, are processed in the clustering process with constraints and give the output clusters as an output. Here for clustering parameters we use algorithms like k-means and density based, and then constraints specified on clusters we use SQL aggregates, which is then followed by the constraints which are imposed by physical obstacles use obstructed distance for clustering. So here in this example, we have clustered 4 items without taking obstacles into consideration. Here the obstacles were river, bridge and mountain, but not taking into consideration, we have just clustered all these items into C1, C2, C3, C4 respectively. In this slide, we talk about similarity search in multimedia data. It is a primitive operation in database and web search engines. In this, we have two type of retrieval systems. One is description based and the other one is content based. Description based build indices and perform object retrieval based on image descriptions such as keywords, captions, size and time of creation. It is labor intensive if performed manually, and the results are typically of poor quality if automated. This is the reason why we go behind content based retrieval system, since it supports retrieval based on the image content such as color, histogram, texture, shape, objects and wavelet transforms. In this slide, we talk about the queries in content-based retrieval systems. The first one goes with the image sample-based queries, where we find all of the images that are similar to the given image sample and compare the feature vector extracted from the sample with the feature vectors of images that have already been extracted and indexed in the image database. And the second most important one goes with the image feature specification queries, which specify or sketch image features like color, texture or shape, which are translated into a feature vector and check whether it matches or not. One more important slide to talk about is multidimensional analysis of multimedia data. A multimedia data cube can have additional dimensions and measures for multimedia data such as color, texture and shape. The database does not store images but their descriptors like the feature descriptor and the layout descriptor, where the feature descriptor contains a set of vectors for each visual characteristic, which includes color, MFC, MFO, which stands for most frequent color, most frequent orientation, and the layout descriptor contains a color layout vector and an edge layout vector. In this slide, we are going to see a keen example of how multimedia databases are mined. Mining is nothing but refining and combining the searches. On the left hand side, as you see, if you want to search for a blue sky, the multimedia database would mine by taking the top layout grid is blue as an example or as a key code. Moreover, moving on to the right one, if you want to search for aeroplane in the blue sky, it would take top layout grid is blue and the keyword as aeroplane as a whole key. And then moving on to the right corner, if you want to search for a blue sky and green meadows, it would take the top layout grid is blue and bottom as green as the keyword. So this is how a multimedia database mines each and everything minutely. Here again I have given you some other example in this slide for you to get a deep understanding about what mining in multimedia is all about. So here we have seen a picture where 3 dolphins are available, and through this picture we are going to take the color texture where the multimedia database availability of that color picture is being recognized, and the next slide goes with the description of the color histogram and the texture layout where the database mined the colors of that particular picture, and it has come to a conclusion that there are 4 colors available and the percentage of that particular colors available in that picture. And the second one goes with the texture layout where 4 textures have been introduced in that picture. So this is a brief description about the real-time application and the example of multimedia data mining, particularly the image data mining in multimedia database. Hey guys, I hope that this video brings you a very good knowledge about what multimedia data mining is all about. I think you're super clear with all these topics which we have learned so far. Thank you for watching. See you soon in next video.